Chapter 1.6, Classify Polygons. Okay, I'm going to give you a summary of the notes here in a moment. Okay, but they say a polygon is a closed plane figure with the following properties. It is formed by three or more line segments called sides. Each side intersects exactly two sides, one at each endpoint, so that no two sides with a common endpoint are collinear. So a summation for the polygon, it has to be three or more sides. Okay, you can't make a polygon. You can't make a polygon with only two sides, and they're line segments only. Okay, you can't have a polygon with a curve or anything like that. A circle is not a polygon. Each side intersects two sides at the endpoints, and it is a closed figure. Okay, you can't have that and say it's a polygon. And as far as each side intersecting 2 points at the endpoints, if you drew something like that resembled a house, that would be a polygon. But if you took an additional line and drew it like that, I'm pretty sure that's not considered a polygon, because now you have a side, let's say that side right there, it intersects here, it intersects this side, and it also intersects that side as well. So it has to intersect only two sides exactly. Okay, each endpoint of a side, that's called a vertex. Okay, and the plural of that is vertices. Let's take a look. So these points, A, B, C, D, E, those are the vertices. All right, singular is vertex and plural is vertices. And it says you name the polygon by listing the vertices in consecutive order. Okay, you can say A, B, C, D, E, or C, D, E, A, B, and so on. I'll show you on the diagram. So you name the vertices in order, and you can start anywhere. Okay, you can go in either direction. So let's say I started at point D. I can call this one D, C, B, A, E. Okay, so that would be D, C, B, A, E. And I can also go around the other direction. I can start anywhere you like. Okay, let's start at point E. We can say E, A, B, C, D. Okay, E, A, B, C, D. So as long as the letters are in order, and you can start anywhere, you can go clockwise or you can go counterclockwise. It doesn't matter. Okay, so this is the difference between a convex and a concave polygon. The concave polygon, it basically has a dent. All right, and the way I remember which one is concave, the concave polygon is basically caved in. Okay, so you see on the concave polygon, there's a dent in the polygon, but the convex polygon, that's not the case. Okay, and if you extended any of the sides on the convex, they wouldn't go inside the polygon. But here, see, they extended one of the sides of the polygon, and you can see right here, it went on the interior, inside the polygon. It went on the interior of the polygon. All right, let's try example 1. Tell whether the figure is a polygon and whether it is convex or concave. Okay, please try A and B for starters. Okay, for part A, the answer is no. Okay, not a polygon. Okay, and you have to remember that a polygon, each side intersects exactly two sides, all right, at their endpoints. Now, if you take this side right here, that side, it intersects It intersects this one right here. It intersects that side right here. And it also intersects that side right there. Okay, that's 3 sides that it intersects, and that can't be the case. It has to intersect only 2 sides. So that one is no good. And they said the same thing for answer A. Some segments intersect more than 2 segments, so it's not a polygon. If it were a polygon, it would be concave because of this dent right here. If we didn't have this line right here, it would have been a polygon. But the answer for A is no. Okay, part B. It's a little bit crooked, but none of the lines are curved. So that is definitely yes. That is a polygon. And there is no dent in the polygon. Okay, so this one is going to be convex. Okay, please try C and D. State if it's a polygon and then convex or concave. Okay, figure C. That is a no. All right, you see this one right here. That's a curved line. Can't have that. Okay, so that's definitely a no. And figure D, that is a yes. Okay, and that has dents in it. Okay, so that is concave. And they said the same thing for C. Part of the figure is not a segment, so it's not a polygon. And D is a concave polygon. All right, classify polygons. A polygon is named by the number of its sides. Let's take a look. All right, so we have this chart here. 3 sides is a triangle. 4 is a quadrilateral. 5 is a pentagon. 6 is a hexagon. 7 is heptagon. 8 is octagon. 9 is nonagon. 10 is decagon. 12 is dodecagon. And anything else, if you have an n number of sides, you can just call it an n-gon. Okay, in other words, let's say you had 17 sides, then you would just call it a 17-gon. All right, I'll give you notes for this section. Equilateral polygon, all sides congruent. Equiangular polygon, all angles in the interior congruent. And a regular polygon is a convex polygon that is equilateral and equiangular. Let's write that out. All right, so for an equilateral polygon, the sides are congruent. For an equiangular polygon, the interior angles are congruent. And a regular polygon is both equilateral and equiangular. And it must be a convex polygon. In other words, no dents. So this right here is a regular pentagon. Notice they marked all the interior angles congruent, and they also marked all the sides congruent. Okay, let's try example 2. Classify the polygon by the number of sides and tell whether it is equilateral, equiangular, or regular, which means it's both of these. Okay, try part A real quick. All right, counting the sides, I see 1, 2, 3, 4, 5, 6. Okay, that's 6 sides. So that is going to be a hexagon. Let me see if I have room here. Hexagon. Okay, 6 sides would make this a hexagon. Hexagon, and if you look at all the sides are marked congruent, and all the interior angles are also marked congruent. So that makes it a regular polygon. Okay, please try the figure in part B. So part B is four-sided, and that would make it a quadrilateral. However, if you look at the sides, one is marked with 2 and one is marked with 1 notch. So the sides are not all congruent. And if you look at the angles, one is marked with 2 and one is marked with 1 arc. So the angles are not congruent either. Okay, please try part C. That's a tough one. All right, counting the sides, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is actually a dodecagon. All right. Now, all the sides are marked with the tick mark, the 1 tick mark. So it is definitely equilateral. But if you look at the angles, they're not all congruent, okay? It has to be the interior angles. Many of the interior angles are right angles, but if you take this angle right here, it goes all the way from here to there, okay? That is not an interior right angle. So it's not equiangular, but it is equilateral. And in their answer, they said the polygon is not convex, so it's not regular. The sides are congruent, so it's equilateral. Yep, same answer. All right, one more of these. Classify the polygon shown at the right by the number of sides. Explain how you know that the sides are congruent and that the angles are congruent. Let's take a look. All right, try this one, please. That's pretty easy. All right, so this is clearly a quadrilateral. Okay, how do we know the sides are congruent? Well, that's easy. They're all marked 2 meters. How do we know the angles are congruent? Well, they're all marked as right angles. So that one was pretty easy. All right, let's try example 3. Table is shaped like a regular hexagon. The expression shown represents side lengths of the hexagonal table. Find the length of a side. Now, the key thing to remember here is that this is a regular hexagon. Okay, so that means all sides and interior angles are congruent. All right, so here's the regular hexagon. They made the side lengths into algebra expressions, but since we said it's regular, we know all the sides are congruent. Okay, so I can mark this side here congruent to that side there. All right, so this one's pretty easy. Just set them equal to each other and solve for x, please. All right, I'm going to do 3x plus 6. And that equals 4x minus 2. Solving for x. I'm going to bring the 3x over to the other side. When there's an x on both sides, usually I subtract the smaller one, so I end up with a positive x. Okay, 3x minus 3x is gone. Plus 2 on both. 6 plus 2 is 8, and 4x minus 3x is 8. Did they ask for the actual side length? Yes, they said find the length of a side. So we want to take that and plug it in. Make sure they're both the same. Okay, so you take that 8 and put it right in there. That's going to be 3 times 8 plus 6. And 3 times 8 is 24, plus 6 is 30. And also take the 8 and plug it in right there. That's going to be 4 times 8 minus 2. Okay, 32 minus 2 is also 30. So it checks out. Makes sense that they're both the same. It's a regular polygon. The sides are congruent. All right, one more easy one to close it out. The expressions 8y degrees and 9y minus 15 degrees represent the measures of 2 of the angles in the table in example 3. Find the measure of an angle. Okay, remember we said this was a regular hexagon. It said it right in the write-up. Okay, so all the angles are congruent. This angle is congruent to this angle, is congruent to that angle. All the interior angles are congruent. All right, so if the angles are congruent, just set the angle measurements equal to each other. Solve for y and plug it back in, please. All right, we have 8y equals 9y minus 15. All right, I like to keep the variable positive, so I am going to subtract the smaller one, which is 8y from both sides. 8y minus 8y cancels. And since I have the y's over here, I want the 15 on the left. So I'm just going to do plus 15 on both sides. All right, 15 minus 15 cancels. Bring down your equal sign. Only thing left on the left-hand side is 15. And 9y minus 8y is 15. All right, you just take that and plug it in. All right, so plugging in y equals 15. 8 times 15 is going to be 80 plus 40. That's 120. And that's in degrees. Let's make sure the other one is the same. Okay, here we have 9y minus 15, so that's just 9 times 15 minus 15. Okay, that's 150. That's 135 minus 15 is 120. And that's in degrees. So same exact thing. Just real quick, I would like to point out, I might give you one of these problems, possibly, okay, but it says each figure is a regular polygon. So when you set these two expressions equal to each other, and you do minus x squared on both sides, the x squared should cancel on both sides, because you just do minus x squared on both sides, and you're left with this equals that. You can easily solve for x. Okay, so if I give you one of these, don't let the x squared intimidate you. Just subtract it from both sides when you set them equal to each other.